Alright, so this is the first review question in kinematics. I'm going to start off pretty simple. Throw a ball vertically upward from a tall building with an upward speed of 15 meters per second. You throw the ball at the edge of the building. Find the ball's position and velocity at 4 seconds, the velocity when it is 5 meters above the railing, the maximum height reached by the ball's acceleration when it is at its maximum height. Alright, so this is a pretty basic kinematics free fall problem. So if you want to take some time right now to try to do this on your own, pause it and work on your own. Alright, so I'm going to start this problem. Maybe if you're having trouble visualizing, the first thing you want to do is draw a picture. So I'm going to draw a picture over here. Tall building, it doesn't say how high it is. This ball gets thrown off the edge and goes down something like this. It starts at 15 meters per second. Alright, so now first question over here. Find the ball's position and velocity. So let's first list off what we know. We know that this ball is going up with the speed of 15 meters per second. So we know V initial is 15 meters per second. We also know for question A, the time we're looking at the ball's position and velocity at 4 seconds. So we know T equals 4 seconds. What's important to know with these free fall problems is always the acceleration that we're going to have when the only thing touching it except gravity is going to be -9.8, or I'm going to put -10 meters per second squared for the sake of the AP test. Okay, so let's find the position. So what we're looking for first, the position, what we're looking for is this change in x. What is this change in x? So we're going to be using one of the formulas. Change in x equals v initial t plus 1/2 at squared. Okay, this is displacement over here. So displacement equals initial velocity, which is 15, t, which is 4, plus 1/2 -10, 4 squared. You calculate this, and you get an answer of displacement equals to be -20 meters, or 20 meters below the top of the building. So that's the first part of A. The second part is asking for what the velocity is. So over here, what we're looking for is the final velocity. And there's two formulas we can use for this, but I'm going to be using this formula right here because it's simpler. V final equals V initial plus AT. We don't know what V final is, that's what we're looking for. V final, V initial is 15 meters per second plus A, -10. And this is at 4 seconds. 4 over here. What we find is the final velocity is equal to -25 meters per second. So that's A right there. Let's go on to question B. So B states the velocity when it is 5 meters above the railing. So same results we have over here. We have our knowns is V initial is 15 meters per second. Accelerations, since it's free fall, is -10 meters per second squared. And now what we know is the position is 5 meters above, so the displacement equals to be 5 meters. And what we're looking for is what the velocity is. So what is that velocity? With this, once we have 3 pieces of information, we can always find the fourth. So V final squared equals V initial squared plus 2A change in x. So this is the formula we're going to use. We're looking for what V final is. V final squared equals V initial squared, which is 15 squared plus 2 -10, 5 over there. This simplifies So when we do this, we get that the final velocity is going to be equal to 11.18 meters per second. Next over here, we're looking for the maximum height reached. So this is the only tricky part with this is, let's list our knowns. V initial, 15 meters per second. Acceleration, negative 10 meters per second squared. And that's all we know. However, it asks for the maximum height reached. And what we should know is when this ball reaches its maximum height over here, for an instant in time, the velocity is going to be 0. So what we're going to say is the final velocity at this point right here is going to be 0 meters per second. Now we have 3 pieces of information. We could always find the fourth after this. And we're looking for the maximum height, so we're looking for displacement. So let's find that. We're going to use the formula that has all 4 of these, and that's the same formula. V final squared equals V initial squared plus 2a change in x. V final 0, V initial 15 squared plus 2 negative 10 change displacement. We do that calculation and we get displacement is 11.25 meters. Last question over here. The ball's acceleration when it is at its maximum height. So a lot of people get tricked up over here. They feel like because the ball isn't moving that the answer is going to be 0. However, the velocity and the speed is going to be 0 meters per second. But what's important to know is whenever the only thing touching it is gravity, or whenever it is in the air, gravity is always acting on it, and gravity is going to be acting on it with negative 10 meters per second squared. So the ball's acceleration when it is at its maximum height, and throughout the whole time it's moving, the acceleration of gravity is going to be negative 10 meters per second squared. All right.